Hello everyone, welcome back to sisyaclass YouTube channel. So we are back with another session for your EAPCET series. Today we are going to discuss about compounds containing oxygen. Okay, so we will cover alcohol, phenols, ethers, carboxylic acid, aldehydes, ketones, each and every organic compound that contains oxygen. We are going to cover all of them in today's session. So how are we going to begin this session? We are first going to understand the concept, right? The preparation, the reactions of alcohol, phenols and ether. Then we will repeat the same thing for aldehyde, ketones and carboxylic acid, and then we will solve questions. And one more thing, please don't try to think that if I know aldehyde, ketones and carboxylic acid, I can easily solve any question related to it. No, it is interrelated to other organic compounds. So they will not ask you a question in isolation that please answer for carboxylic acid, please answer for aldehydes, please answer for ketones. No, they will relate it to other organic compounds. So let's say they will start with alcohol and then in a few steps they will ask you to relate it to your carboxylic acid. So you should know both of these things in order to answer the question completely, and you will find multiple such questions in which steps are involved and they are interrelated. So you have to understand that thing, that you have to know the organic chemistry as a whole. It will not work in isolation. Okay, so before we begin with our session, let me introduce myself. I hope you are following the EAPCET series. I hope you are regularly watching all these sessions. It will help you immensely. And regarding what type of past year questions you have to study for this examination, right now you don't have the time to go into detail. Yes, you have to solve past year questions in order to secure good marks in any competitive examination. Same for EAPCET. And try to solve questions from last 5 years. Don't go any further than that because those questions are now repetitive. Okay, so last 5 years questions that you have to practice and you will definitely score good marks after that. Okay, so let me introduce myself, then we are going to begin with our session. So my name is Nidhi. I have done my post-graduation from IIT Bhubaneswar. I have 6+ years of experience teaching NEET, JEE and other competitive examination, and in today's session we are going to cover oxygen containing organic compounds. So I hope you are ready. I hope you have revised something from your side, because as you can see on our YouTube channel, all the upcoming sessions are already scheduled. So you can plan accordingly. We always connect at 3:30 p.m. for our chemistry classes. So note this time and try to be ready with your questions also, with your content also, and with your revision also. Okay, let's begin. So first of all, what are we going to cover in today's session? As I have already told you, we will talk about the preparation and properties of alcohol, phenols and ether. Then similarly, preparation and properties of aldehyde, ketones and carboxylic acid. We will start with alcohol, phenols and ether because I told you everything is interconnected. Try to connect them together. From alcohols, how will you prepare aldehydes, ketones, carboxylic acid, what type of oxidizing agent you have to use. Then go in reverse also, that from carboxylic acid how you can prepare the alcohol, what type of reducing agent we must use. From aldehyde and ketones how we can prepare alcohol, like that. Try to interconnect the different topics, then only you will score good marks. Okay, so let's begin. So in here obviously we are not going to cover each and everything. We are just going to cover the important parts and not in detail because you have already done that. We are just trying to revise something before we start with our question so that you can understand everything very quickly and you can apply that information while we are solving question. That is our only aim. We are not trying to teach you the entire part because that will take time obviously. Okay, so hydration of alkenes. As you all know, alkenes can be hydrated in the presence of sulfuric acid as a catalyst. Okay, do we have to remember this information that sulfuric acid is used as a catalyst? Yes, you must. And what is the final product? Alcohol. We are trying to prepare alcohol. So we can prepare alcohol by electrophilic addition of water. They can ask you this question also. What type of reaction is shown here? So you must know that this is electrophilic addition. Okay, then we can also do hydroboration oxidation. See, when we add water, we are trying to make a stable carbocation. That is how you decide the final product. And generally, it follows Markovnikov's addition. Okay, I am going to write it here. What is Markovnikov's addition? If you have some unsymmetrical alkene, okay, not symmetrical, and you are adding a unsymmetrical reagent. So there will be possibility of two products, right? So how do we decide which one is the major product? If you are following Markovnikov's addition rule, the unsymmetrical reagent that you have taken, the negative part of that reagent will add to that carbon atom which has less number of hydrogens attached to it. This is what we mean by Markovnikov's addition. I will write it. Negative part will attach to carbon with less hydrogens or more substituted carbon, however you want to call this carbon atom. Less hydrogens attached to it or less substituted carbon atom. So the positive part will go to that carbon atom which has more hydrogens attached to it. I will not write that entire thing because now you understand. You are very much capable of understanding this statement. You have learned this thing. Okay. This is Markovnikov's addition rule. What do we mean by anti-Markovnikov's addition rule? Just do the reverse. In that case, negative part of the reagent will add to that carbon atom which has more number of hydrogens attached to it. Just do the reverse. Okay. So in this case, we are doing Markovnikov's addition. Or you are trying to form a stable carbocation, and after you have formed the stable carbocation, you will attach the hydroxy group to that carbon atom. So you can follow modified Markovnikov's rule also. Modified Markovnikov's rule. What happens in case of hydroboration oxidation? In hydroboration oxidation, you will follow anti-Markovnikov's rule. Do we have to remember this information? Yes, you must remember this information. Otherwise, your entire question will be wrong. So we will do one such question today. So I hope you will remember this concept and apply it while solving the question. Okay. Reduction of carbonyl compounds. Now aldehydes can be reduced to 1 degree alcohol by using reducing agent like lithium aluminium hydride. Very strong reducing agent, can reduce aldehydes, ketones, carboxylic acid, ester. Strong reducing agent. Sodium borohydride, a mild reducing agent, can be used for aldehyde and ketones. If you want to reduce your carboxylic acid, your sodium borohydride will not show anything. So you must remember this information also. Okay. Then from ketones, what type of alcohols you will get? Secondary alcohols. Do we have to remember that also? There is no need to memorize it per se. If you see the structure of ketone, you will come to the same observation. But if you know the effects clearly, you can use it to solve questions also quickly. Okay, then you will not need the time to think that what should I make, should I draw the structure or not, if you know the effect. But if you know the structure, then also you will come to the same observation. It will not take much amount of your time, but try to revise everything once. Okay. Next, Grignard reaction. By that also we can prepare alcohol. So Grignard reagent, an addition of water will give you alcohol. You have done this in the last session. If you remember, when we were talking about haloalkanes and haloarenes, we have done multiple such questions in which we have prepared some hydrocarbon in the end, right? So that reaction was with alkyl halide. In this case, we are talking about addition of water directly to the Grignard reagent. There we have prepared it also. Okay. Next thing, dehydration. What type of reactions are shown by alcohol? What is dehydration? Loss of water. Elimination reaction. So if you do dehydration of alcohol, hydroxy group will be removed from one carbon atom, hydrogen from the adjacent carbon atom. We are going to do beta elimination. You have done this also in the last session. If you don't remember these things, try to revisit the last session. You will get this information there. We have talked about beta elimination, alpha elimination there only. Okay. So alkene formation by beta elimination, everyone. There will be loss of water. Loss of water. Okay, great. Then what type of oxidation reactions are shown here? 1 degree alcohol, if you want to oxidize it to aldehyde, we have a special oxidizing agent. You know all about it, PCC, pyridinium chlorochromate. It can be used to oxidize your alcohol up to aldehyde. If you want to do over oxidation, I want to prepare carboxylic acid, use a stronger oxidizing agent like KMnO4. Okay, so in order to achieve the required product, you can change the reagent. You must remember the reagent for that. Okay, from secondary alcohol, you cannot over oxidize it from ketone. You will get ketone whether you take a weak reducing agent. Whether you take a weak oxidizing agent or a strong oxidizing agent, from secondary alcohol you will get ketone. Okay. What about tertiary alcohol? Tertiary alcohol will not show oxidation. You have to break carbon-carbon bonds for that. Okay. So don't worry about tertiary alcohol. Primary alcohol can be oxidized to aldehyde. You want to do over oxidation, take a strong oxidizing agent. Okay. And from secondary alcohol you will get ketone only. Alright. Now Lucas test, very, very important. First of all, they will ask you which one of the following is your Lucas reagent. So you should know that. Okay. So anhydrous zinc chloride and concentrated HCl, this is your Lucas reagent. You should know the reagent first of all. Then you should know the use of Lucas reagent. It is used to distinguish between primary, secondary and tertiary alcohol. Primary alcohol, when you add Lucas reagent to it, it will show instant turbidity. That turbidity represents the formation of alkyl chloride. Okay. What about secondary alcohol? If you add Lucas reagent to it, it will give you the reaction, but after some time, maybe 5 minutes, 10 minutes. And if you have a primary alcohol, forget about turbidity. It will not show any turbidity at room temperature. You heat it, then after some time, maybe a day, you will see some reaction, otherwise not possible. So that is how you can distinguish between tertiary, secondary and primary alcohol. Tertiary alcohol, instant turbidity. Secondary alcohol, after some time. And primary alcohol, there will be no reaction with Lucas reagent. Very important concept, and remember the name of the reagent. Okay. See the next thing now. Then we have phenols. This is your phenol. Okay. How do we prepare it? With the help of Dow's process. See, the nucleophilic substitution of aryl halide is very difficult because of the double bond character. You already know the effect. But under very high temperature and pressure conditions, yes, you can do the substitution. Difficult, but we can achieve it at a very high temperature and pressure condition. Do we have to remember those temperature and pressure conditions? You must. Okay. So this is your Dow's process. Please remember the temperature and pressure conditions. They can ask these conditions directly. You don't have to remember it for each and every reaction. I'm not saying that. But for some reactions, the high temperature and pressure is the very required condition. Try to remember the information. For example, for Dow's process. Okay. Next, we can also prepare it by cumene process. We will do one such question today. I am writing the reaction here. This is your cumene. Okay. We also call it isopropyl benzene. On oxidation, this will give you cumene hyperoxide. And then on further reaction will give you phenol and acetone. So sometimes they ask you the structure of this intermediate also. You must remember it. Okay. So that this is another way by which you can prepare phenol. Important reaction. You must remember the reaction. Okay. Now this is all about the preparation of phenols. What about the reactions? If you compare the acidic nature of alcohols and phenols, such questions are also asked. Which one is more acidic? So in case of phenols, your oxide group is directly linked with a benzene ring. That can show resonance. In case of alcohols, it will be attached to some alkyl group. How do we compare the acidic nature of different groups? We talk about the stability of anion we have formed. So how do we compare the stability of anion? If electron withdrawing groups are attached to it, it will stabilize your anion and it will increase your acidity. If some electron donating group is attached to it, it will destabilize your anion and decrease your acidity. So in comparison to your alcohol, this is the alkoxide ion, this is your phenoxide ion. This is much more stable because of the minus M effect of aromatic ring. So because of the minus M effect of aromatic ring, this conjugate base is stable, and greater the stability of conjugate base, more will be the acidic nature. Alright, that is how you can answer the question. So this is what we have written here. Alright. Then what other type of reactions are shown by it? We can also see electrophilic substitution reaction in case of phenol. Okay. So aromatic electrophilic substitution. So since this OH group is a strong electron donating group, activating group, it is an electron donating group, right? It will increase the electron density on your aromatic ring. Because of that, if you do bromination, you expect some ortho-para product to get formed. You will get ortho-para substitution in one single compound. Multiple substitutions will take place. This multi-substitution is because of the strong activating nature of your hydroxy group. Can be asked in a question. Okay. So your product will be 2,4,6-tribromophenol. Similarly, if you do nitration, you will get orthonitrophenol and para-nitrophenol. Para-nitrophenol will be your major product. They are concerned with the major product. Remember the major product always. Okay. Then we have Remer-Tiemann reaction. Again, important reaction. We will solve one question today based on Remer-Tiemann reaction. So phenol on reaction with chloroform in the presence of NaOH will give you salicylaldehyde. This is salicylaldehyde. And a very similar reaction in which we form salicylic acid. Okay. Salicylaldehyde at ortho position you have a aldehyde group. Salicylic acid at ortho position you will have a COOH group. You must remember these two reactions. Okay. This is Kolbe's reaction. You will find such questions in which they have given you the entire reaction, the reactant also, the product also, the reagent also, and their question would be, can you identify the reaction? So your name reactions are so important. They will ask you just the name of the reaction that you have studied, nothing else. Okay. So try to revise the name reaction. Please focus on the name reactions. Okay. Next thing. Then we have ethers. So we are done with alcohols, we are done with phenols. Now let's talk about ethers. Okay. So ethers, how are we going to prepare it? With the help of Williamson synthesis. So what are we doing here? Substitution reaction, everyone. SN2, substitution, nucleophilic, bimolecular. Okay. So this is your nucleophile. It will attack your electron deficient center and it will replace this halogen. This is your leaving group. And as a result, you will get this kind of ether. Now, what is important in this Williamson synthesis, since we are talking about substitution, nucleophilic, bimolecular, what type of alkyl halide we should start with? Can we start with a tertiary alkyl halide? No. Please start with a primary or secondary alkyl halide, because you know SN2 reaction is favored in primary and secondary alkyl halide. In tertiary alkyl halide, instead of seeing this kind of substitution, some kind of elimination will take place. We don't want that. Okay. Some kind of alkene will get formed. We don't want to prepare some alkene. We are trying to prepare ether. Okay. So what type of alkyl halide we must take? Primary and secondary alkyl halide is okay for us. Primary is the best. Please never take a tertiary alkyl halide. That will not give you any type of Williamson synthesis. Okay. Then we can do dehydration of alcohols also. Okay. That will also give you ether. Again, what type of alcohol you should start with? Don't start with a tertiary alcohol, because in tertiary alcohol also you already know dehydration will take place. Instead of forming ether, you will form alkene. We don't want to prepare alkene. We are trying to prepare ether. Okay. So again, avoid tertiary alcohol. Alright. Then what type of reactions are shown by it? So you can see acidic Bond breaking, acidic cleavage by hydrogen iodide or hydrogen bromide. We will solve such questions also. Okay, and what type of product you will receive? Some kind of alkyl halide if you have taken HBr alkyl bromide, if you have taken HI alkyl iodide, and along with that alcohol. Okay, then anisole. What is anisole? This is anisole. Methyl phenyl ether. Similar type of reaction as you have seen here. We just have some aromatic part in it. Just like we have covered alcohol, then phenol, aromatic ring directly attached to OH. Like that we can have alkyl ether, alkyl aryl ether. So this is an example of aryl ether. It has both alkyl as well as aryl group. Okay. Then what is next? Now we are done with alcohols and phenols. What type of reactions are shown by aldehydes and ketones? See, in aldehydes and ketones, we have a separate set of reactions. Carboxylic acid is different from it. So we are going to compile aldehydes and ketones together, and we will talk about carboxylic acid separately, because the type of reactions which are shown by aldehydes and ketones are also very similar and very different from your carboxylic acid. Okay. So what is the functional group here? We all know CHO. In ketones, it is CO. Two alkyl groups, they could be same, they could be different depending upon what type of ketone you are talking about. Okay. Then how do we do oxidation of alcohols? If you do oxidation of 1 degree alcohol, you will get aldehyde, provided you have taken a mild oxidizing agent. As we have covered in the beginning, 1 degree alcohol will give you aldehyde with mild oxidizing agents such as PCC. If you take a very strong oxidizing agent like KMnO4 instead of PCC, what is the product you will receive? Carboxylic acid. Okay, so I hope you understand how alcohols and aldehydes are interrelated, how you can relate it to ketones also, carboxylic acid even. Okay. Secondary alcohol, whether you take a mild oxidizing agent or strong oxidizing agent, it can only give you ketone. It will not over oxidize to give you carboxylic acid. So you can chill about that. Okay. Then ozonolysis of alkene, the simplest set of reaction that you will find in organic chemistry is ozonolysis reaction. What we do in ozonolysis reaction, please see one example. You have some alkene. Okay. This is your alkene, you are doing ozonolysis. You can have reductive ozonolysis, you can have oxidative ozonolysis also. We are talking about reductive ozonolysis, in which you don't have to do over oxidation. Okay. So reductive ozonolysis, zinc is present. That is your deciding factor. Okay. So what are we going to do? Just break the pi bond and connect the two carbon atoms which were originally attached with double bond. You must connect them with a double bonded oxygen and your task is done. Okay. So I will break this double bond. Simple enough. I will attach this carbon with a double bonded oxygen, this carbon with a double bonded oxygen. That is your entire reaction. That is all you have to do. You don't have to show them the mechanism. So you don't have to worry about it. So ozonolysis reaction, wherever you see alkene, you will break that alkene bond and connect those two carbon atoms with a double bonded oxygen and you are done. If it is reductive ozonolysis, that is the entire thing. If it is oxidative ozonolysis, try to oxidize your aldehyde to carboxylic acid. Ketone remains as it is. That is your entire reaction. So in this case, what will you receive? Aldehyde. 2 moles of aldehyde because I have 2 such units, correct? One from here, one from here. This is your ozonolysis reaction. We will solve one question based on ozonolysis also. Okay. What is next? Then we can also prepare aldehyde separately. These were the common reactions that we have covered. That from alcohols you can prepare it, right? By ozonolysis you can prepare aldehydes and ketones. Great. What is the special important method of preparation of aldehyde only? So we can do Rosen-Mundt reduction. Is it important? Every name reaction that you see is automatically important. You have to revise it multiple times. I want you to write all the name reactions on separate notes and revise them before the examination. Revise them multiple times. You have to cram them. They will come to you directly. They can ask you the reagent, they may ask you the final product, they may ask you the name of the reaction even. But they will definitely ask questions from name reactions. Okay, so Rosenband reduction, H2 in PDBSO4, this is your poison. This will give you aldehyde. So there is reduction of acyl chloride RCOCl to RCHO. Now why are we taking this palladium in BSO4? Why are we not reducing it with H2 only? Because if you only take H2, you will receive alcohol. We are not trying to prepare alcohol here. We are doing partial reduction only to aldehyde. We don't want to reduce it to alcohol. If you remove this PDBSO4, the poison that you have taken here, you will get alcohol. You are not trying to prepare it. So PDBSO4 is very important. Okay. Similarly, we already know about Friedel-Crafts alkylation, acylation. We have done that already. So you can also prepare it with the help of Friedel-Crafts acylation. Okay. So this is also a type of electrophilic aromatic substitution. Electrophilic aromatic substitution. Okay, see the next set of reactions. Nucleophilic addition. See, in case of aldehyde and ketones, we can't do substitution reaction. In carboxylic acid and its derivatives, plenty of substitution reactions are possible, but in aldehydes and ketones, there will be no nucleophilic substitution reaction because there is no leaving group here. What type of reactions will be shown by aldehydes and ketones then? Nucleophilic addition reactions are shown. Substitution is not possible. Please don't try to substitute anything in your aldehyde and ketone. Okay, so you can do nucleophilic addition reaction, yes, for sure. So on addition of hydrogen cyanide, you will form cyanohydrin. Why we have written cyanohydrin? Will they ask you about the name of the product also? Yes, they may ask you the name of the product also. They may ask you the structure also, name also. So names are also important when you study about nucleophilic addition reaction of aldehydes and ketones. Keep that in mind. I have to remember the names also. Okay. With sodium hydrogen sulfide, you will get the bisulfite adduct. Oxidation, again we have done this already. If you want to oxidize your aldehydes to carboxylic acid, start with a strong oxidizing agent like KMnO4, K2Cr2O7, potassium permanganate, potassium dichromate. They will oxidize your aldehyde to respective carboxylic acid. RCHO will oxidize to RCOOH. Ketones resist oxidation. That is why we were talking about that if you take a secondary alcohol and you take a mild oxidizing agent, you take a strong oxidizing agent, you don't have to worry whether I will receive some ketone or carboxylic acid. It will oxidize up to ketone only. Oxidation of ketone further is very difficult. You require special reagents for that. High temperature is required for that. Carbon-carbon bond breaking is required for that. So it is not as easy as oxidation of aldehyde to carboxylic acid. So you don't have to worry much about it. Okay. So it is possible only under vigorous conditions. Under normal conditions, it is not possible. So unless and until it is specially mentioned in the question that please oxidize this ketone to carboxylic acid, you will not break any carbon-carbon bonds. Please don't over-oxidize ketone. Oxidation of aldehyde to carboxylic acid, easy peasy. You see KMnO4, K2Cr2O7, please oxidize it. Okay. What is next? Reduction also. You have seen this already, that aldehydes on reduction will give you a primary alcohol, ketones on reduction will give you secondary alcohol. This is the reverse of what we have seen in the beginning. So don't worry too much about it. If you know about oxidation of alcohol to aldehyde and ketone, you already know about reduction of aldehydes and ketones to alcohol. These are the reverse reactions. Okay. Then special reaction. Now this is important. Clemmensen reduction. See, what is so important about it? In this reaction, aldehydes and ketones were getting reduced to alcohol, right? See, in this case, you are forming a hydrocarbon. You are not reducing it to some alcohol. You are forming a hydrocarbon here. So that makes it important. Do we have to remember the reagent? You must remember the reagent here. Okay. So this is Clemmensen reaction, zinc mercury amalgam in the presence of HCl. So you will receive hydrocarbon here. Okay. Then what is the distinguishing test for aldehydes and ketones? That aldehydes will give you a positive tolerance test. Ketones will not give you this reaction because you cannot over-oxidize ketones. You cannot form carboxylic acid from them. So that is how you can distinguish between the two. Okay. So what can they ask you? That which one of the following is your tolerance reagent? Ammonical silver nitrate solution. And this will finally give you this kind of complex, AgNH3 whole twice with a plus charge. You must remember the reagent. Okay. Then Felling's test, your aldehydes will also give you a positive Felling's test. And what is the final product received? Brick red PPT. You must know the final identifying factor. In tolerance reagent, you will form a silver mirror in the end. That is how you identify it. Some kind of color change, some kind of new PPT, some kind of precipitate getting formed. Those are the identifying reaction. That is how you distinguish between the two compounds. Okay. Then we have Wolff-Kishner reduction. See, here we have written Clemmensen reduction. Wolff-Kishner reduction is also quite similar to it. How? Because in here also you will get the hydrocarbon. So these are some of the important sets of reaction that you must know about aldehydes and ketones. Now let's cover the last thing, then we will solve questions. Okay. Carboxylic acid. The functional group obviously is COH, you all know about it. How do we prepare carboxylic acid? By oxidation of primary alcohols. Everyone, please don't try to oxidize secondary alcohols. Okay. A secondary alcohols on oxidation will give you ketone. Then in order to oxidize ketone to carboxylic acid, you require very vigorous condition, very high temperature. You all know about it. Okay. But how do we oxidize our alcohols to carboxylic acid? Directly, everyone, with a very strong oxidizing agent. Oxidation of aldehydes to carboxylic acid, one step. Oxidation of alcohols to carboxylic acid, you will oxidize alcohols to aldehydes first, then those aldehydes will convert to carboxylic acid. That is why strong oxidizing agent is required. Okay. Then we can also do hydrolysis of nitrides. That will also give you carboxylic acid. Okay. Then acidic nature. Carboxylic acids have high acidic strength than alcohols, then phenols also. Okay. Why? What is the reason? Equivalent resonating structures, everyone. Equivalent resonating structures. See, resonance was possible in phenol also. Okay. I'm not saying resonance was not there. Yes, it was in resonance with the aromatic ring. But in here we have equivalent resonating structures. So they will take precedence over your normal resonance. Okay. So they are stronger than phenols and alcohols due to resonance. And how they are stronger than phenols? Because of equivalent resonating structures. Okay. Finally, the reactions. We can do decarboxylic reaction with NaOH and soda lime. So what happens in decarboxylation? The name itself tells you everything. Decarboxylation, removal of CO2 to give you some kind of hydrocarbon. Okay. So loss of CO2. Decarboxylation. And what you will get in the end? Hydrocarbon. Esterification reaction with alcohols. So your carboxylic acid with alcohols will give you ester. Reaction of carboxylic acid with alcohol will give you ester. Okay. This is what we mean by esterification reaction. Again, important. Okay. Reduction, you can reduce it to alcohols with the help of lithium aluminium hydride. Remember, When we were talking about reduction of aldehydes and ketones, I told you, in order to reduce aldehydes and ketones, we can use sodium borohydride, we can use lithium aluminium hydride. Sodium borohydride is a weak reducing agent. Sodium borohydride is not capable of reducing your carboxylic acid. You need something stronger like lithium aluminium hydride. Okay, so please remember, you cannot use sodium borohydride here. This will not give you the reduction reaction. Very important observation. Please remember it and try to make a table of different oxidizing and reducing agents. What are their functions? What type of functional group they can oxidize? What type of functional group they can reduce? What type of functional groups they will not work on? You have to remember that information. Okay. See the next thing. Let's start with the questions, everyone, now. So we are done with the concepts. Please read the question. Now you will find the questions very easy because you are done with the concepts. Okay. So let's start with the first question. A Grignard reagent X on reaction with some carbonyl compound Y followed by hydrolysis gives you Z. Now Z reacts with concentrated HCl at room temperature. What is X and Y in this reaction? See, Z. What is your Z? That gives you a hint. If this is your Grignard reagent, I don't know what is the value of R. Let's write it RMGX. Okay. It reacts with some carbonyl compound. I don't know what is that carbonyl compound also. But we all know if Grignard reagent is reacting with some carbonyl compound, it is going to give us some kind of alcohol in the end. This is how you will come to the correct answer. Okay. So I will just write carbonyl compound here. I don't know which one. And in the end, you will get some kind of alcohol. Now, what type of alcohol we will receive? That you can decide by this statement. This is Z, right? This is alcohol. This is X. This is Y. So, Z reacts with concentrated HCl at room temperature. They are talking about Lucas reagent, everyone. What type of alcohol will react instantly with your zinc chloride and HCl mixture? At least it will show you the reaction. Either primary or secondary alcohol. Sorry, either secondary or tertiary alcohol. Primary alcohol will not give you this reaction. So leave primary alcohol out of the picture. It is either secondary or tertiary. And to be very honest, it will be tertiary alcohol only. That is why they have given you the statement. So you just have to identify what type of carbonyl compound on reaction with your Grignard reagent gives you a tertiary alcohol. So we have a set of table for that also. Write it down. So Grignard reagent, when it reacts with formaldehyde, the simplest aldehyde that is known to us, gives us primary alcohol. When that same Grignard reagent reacts with any other type of aldehyde, anything except formaldehyde, it will give you secondary alcohol. And when that same Grignard reagent reacts with some ketone, any ketone, it will give you tertiary alcohol. So this is what you have to remember. Please write this down. This is very, very important. What I have told you, that if you have a Grignard reagent, it reacts with formaldehyde, the simplest aldehyde that is known to us. It will give us primary alcohol. If it reacts with any other aldehyde except formaldehyde, secondary alcohol. If it reacts with ketone, it will give you tertiary alcohol. So what type of reaction we are looking for? We are looking for the formation of tertiary alcohol. So your Grignard reagent must react with some kind of ketone. That is your hint. Now see the options. So in this case, they have given you aldehyde, leave it. In this case, they have given us a ketone. This could be our answer. Formaldehyde, not possible. Aldehyde, not possible. Done. This is your X compound, this is your Grignard reagent. It is reacting with this ketone, and this is your final product. You don't have to show this exactly. I'm just telling you what type of reaction is taking place. Your answer is over once you understand we have to form the tertiary alcohol. And how do we form tertiary alcohol from Grignard reagent? By reacting it with some ketone. That is all. Okay. So, option B is your correct answer. Let's see the next question, everyone. An alcohol X, we don't know what type of alcohol. They have just given us the formula C4H10. Oh, okay, great. C4H10, no. Does not give turbidity with concentrated HCl and zinc chloride at room temperature. See, two questions back to back from Lucas reagent. What type of alcohol does not give you turbidity at room temperature? We all know now. 1 degree alcohol. 1 degree alcohol does not react with the Lucas reagent. Only tertiary and secondary alcohol gives you Lucas test. So what type of alcohol they are talking about? This is for sure a primary alcohol. One degree alcohol. Great. Read the second statement. This alcohol on reaction with reagent Y gives you Z. What are X, Y and Z respectively? So what is your reagent Y? Let's see. We have different options. So we will decide based on the option. First of all, you have to identify a primary alcohol. Wherever you see a secondary or tertiary alcohol, just neglect that option. Eliminate it. Okay. Don't waste your time there. So this one is your primary alcohol, could be our answer. Primary alcohol could be our answer. This one is, please see, a secondary alcohol, leave this. A tertiary alcohol, leave this. These two can't be our answer. So your answer is either A or B. Okay, let's see A. Primary alcohol on oxidation with PCC. A mild oxidizing agent will give you aldehyde. Mild oxidizing agent must form aldehyde. So we are forming aldehyde. Yes, this looks okay. What about this one? This is a strong oxidizing agent, everyone. KMnO4 is a strong oxidizing agent. On oxidation of alcohol, it will give you carboxylic acid. It will not stop the reaction at aldehyde. It can't because of its high oxidizing properties. So PCC giving you aldehyde is the correct answer. So this is correct, this is wrong. So that is how you eliminate the option. It was easy once you remember the Lucas test, that it could be only 1 degree alcohol because it will not give you the turbidity at room temperature. This is what you have to remember. Okay, see the next thing. The pK values of X, Y and Z respectively are. First of all, understand what is pK. Acidic strength is directly proportional to your Ka value. Okay, and it is inversely proportional to pK. So higher the acidic strength, lower the pK value. So you don't have to compare pK here. You have to compare the acidic strength, everyone. Once you understand the acidic strength, you will come to the correct answer. Now let's go back to the question. Let's compare the acidic strength. So you have metanitrophenol, you have paranitrophenol, and you have parahydroxytoluene. Okay, let's compare their acidic strength. Okay, let's write this. And a methyl group. Now please see, you are trying to compare the acidic strength. How do we compare acidic strength? Any question comes. Try to remove a proton. form the conjugate base and look for the stability of conjugate base. If your conjugate base is stable, your acidic strength increases. If your conjugate base is unstable, your acidic strength decreases. Okay, so I will write this here, stability of conjugate base. And how do we stabilize conjugate base? It is a negatively charged species, right? How do we stabilize something which is negatively charged? How do we make it neutral? By withdrawing the electron density from it. That is how you remember. You want to make everything neutral. If someone is negatively charged, you want to take the electron density. If someone is positively charged, you want to give the electron density. Okay, so how do we stabilize this negatively charged species? By attaching strong electron withdrawing groups to it. Okay. And what we have to avoid? Electron donating groups. See, I have written the entire thing. Please note it down. It will help you in solving any question related to comparison of acidic strength. Okay. So, is NO2 an electron withdrawing group? Yes, it is. It is present at para position to your hydroxy group. Yes. So, it will exert minus M effect. Correct. What about this one? This is present at meta position. So at meta position, there is no mesomeric effect. Please don't apply mesomeric effect at meta position. Only inductive effect is present at meta position, no inductive effect. Sorry, only inductive effect is present at meta position. There is no mesomeric effect at meta position. Okay. So here we have only minus I effect. That is also okay. At least it is electron withdrawing, but not as strong as the para-nitro group. What about this methyl group? This is an electron donating group, everyone. It will increase the electron density. We want to avoid electron donating group. So this one will have the least acidic strength. Okay. So if I compare the acidic strength, this will be the order. This is the order of acidic strength. Let's label these compounds also. So this is X, Y, Z. X 8.3, Y 7.1, Z 10.2. If I arrange them on the basis of acidic strength, the one with the least value of pK will be most acidic, followed by X, then Z. If I label them based on their pK values, this will be my order. Correct? Now, on the basis of that, just label the compound Y, X, Z. This is Y, this is X, this is Z. Now, see the options in which they are written as Y, X and Z. That will be your correct answer. Okay? So, X is para-nitrophenol. X is para-nitrophenol. This one. Para-nitrophenol. This is X. This is X is para-nitrophenol. Y is, sorry, X is meta-nitrophenol. Y is para-nitrophenol. Okay. X is meta-nitrophenol. Y is para-nitrophenol. And Z is a methyl group at para position. So we will call it as para-cresol. Okay. This is the common name that you should know about, para-cresol. So option A is your correct answer, everyone. So whenever you see a question related to acidic strength, Ka value comparison, pK comparison, always follow this order. This one which I have written here, stability of conjugate base increases, acidic strength will increase, Ka will increase, pK will decrease. And how do we compare the stability of conjugate base? By attaching strong electron withdrawing groups to it. Electron donating groups will decrease the acidic strength. Okay. See the next question. Which of the following belongs to benzylic alcohol type? See, this is benzylic position, everyone. This is your benzylic carbon. So anywhere you see this benzylic carbon, that will become your correct answer. Just draw the structure, you will come to the correct observation. Okay. So you have 1 phenyl, 2 propane, all. one phenyl. At second position, you have phenol. So this is not looking as our correct answer, leave it. One phenyl, one propanol, this is correct. At this is your benzylic carbon, option B is correct. Okay, so just remember the benzylic position, after that it is easy. You must have a hydroxy group attached to the benzylic position. Okay, see the next question. Identify the major product Y in this given sequence of reaction. What are we doing here? Elimination reaction, beta elimination to be exact. So what are we removing? From the alpha carbon, see I told you this thing in the last session. Try to revisit that session if you are not aware of beta elimination. We have covered it in great detail. Okay. So what happens in beta elimination? From the alpha carbon, remove the leaving group, that is bromine. From the adjacent carbon atom, you will remove adjacent beta carbon atom, you will remove the hydrogen and you will receive some kind of alkene as the final product. Okay. So bromine from here, hydrogen from here. So this is your product X, this alkene. Now what is this thing which is given to us? This is hydroboration oxidation. Okay, this is hydroboration oxidation, and you have just now learned this concept that in hydroboration oxidation we do anti-Markovnikov's addition. Anti-Markovnikov's addition, negative part of the reagent will go to that carbon atom which has more number of hydrogens attached to it. Okay, so this will be your final product Y. Anti-Markovnikov's addition. So this is the primary alcohol that you will form. See the options now. This is your correct answer, option B. I hope you are following that. You have learned the concepts already. You should know how to apply them now. Okay. I hope it is easy peasy for you. Let's see the next question. Which of the following reactions takes place when tertiary butanol is passed over heated copper at 573 Kelvin? Now this is also a set of reaction that you should know about. I will write the 3 sets of reaction, note it down, apply it yourselves. Okay. So when you have a primary alcohol, copper 573 Kelvin, same reagent, copper 573 Kelvin. From here you will get some aldehyde. From here you will get ketone. And from here you will get some alkene. Elimination will happen. Okay. So that was your question, right? You are given with a tertiary alcohol here. It reacts with copper at 573 Kelvin. You will form some kind of alkene. That is your final answer. Done. So what type of reaction is taking place, everyone? Dehydration, right? In these two cases, you are doing dehydrogenation. There is loss of H2 in these two cases. There is loss of water in the third case. Dehydration. Okay. See. Which option talks about dehydration? This one. Option B. Alright. See the next question. The major product of the following reaction is. See, in the last question they have asked you what are you going to do. Are you going to do dehydration? Are you going to do dehydrogenation? And in this question they are asking you the structure of the compound form. Do the dehydration, then now you know the concept. Okay. So there will be loss of water and there will be some alkene which will be formed. So there is no alkene here, no alkene here, no alkene here. This will be our correct answer and you are done. So there are a handful of concepts which are repeated in multiple ways. Okay, so the same concept can be asked in the form of final structure. Same concept can be asked in the form of observation that you have for the reaction, that what actually are we doing. They can ask you the name of the reaction even. Such simple questions are also asked. Okay, let's move to the next one. Match the following. They're just asking you the reagent. Done. They are not asking you the final products. They are not asking you the type of reaction. They are just telling you to identify whether you know the reagent. That if they tell you Lucas reagent, do we know that it is zinc chloride plus HCl? That is all. Okay. So Lucas reagent is, we have done so many different questions based on it. Anhydrous zinc chloride and concentrated HCl. Clemmensen reduction, remember? From aldehyde on reduction, we have formed some hydrocarbon, complete reduction, complete removal of oxygen. You have formed some kind of hydrocarbon, zinc mercury amalgam in the presence of HCl. See, zinc mercury amalgam in the presence of HCl. Okay, Tollens reagent, ammoniacal silver nitrate solution, which will give you this particular complex. Then we have Stephens reduction, in which we reduce a cyanide group. Okay, Stephens reduction, cyanide group can be reduced to aldehyde. Okay, so what will be our correct answer? A matches with 4, A matches with 4, these two are wrong. B matches with 3rd, B matches with 3rd, or B matches with, sorry, A matches with 3rd, Clemmensen's reagent is B matches with 4th. A matches with, oh I am so sorry. Okay, don't do this silly mistake that I have done, that after solving the question we are not matching the options correctly. A matches with 4th, okay. B matches with, alright, 3rd, 4th, okay, these two are same. Tollens reagent is 2nd, okay, this is your correct answer, okay. So, take your time while finally answering the question. Don't answer in a hurry that you give the wrong answer like I have done here, okay. Don't do this silly mistake. Let's see the next question. Assertion: chlorobenzene is not formed in the reaction of phenol with thionyl chloride. Reason: in phenol, carbon-oxygen bond has partial double bond character. See, we have done this kind of question in the last session also when we were talking about haloalkanes and haloarenes. We have learned that the nucleophilic substitution in case of aryl halides is not that simple. Why? Because of the partial double bond character that exists between the aromatic ring and your halogen. Okay, so this is your chlorobenzene, right? So you are thinking I will just replace this chlorine. Sorry, so you are thinking I will just replace this OH with this chlorine by reacting it with thionyl chloride. It is not as simple as that. The nucleophilic substitution on the aromatic ring, it requires very vigorous conditions. It will not happen at room temperature under normal conditions, first of all. Okay, so this statement is true that you cannot form it directly by the reaction of thionyl chloride. Okay, then the reason is also correct, that there is this double bond character which exists between this carbon hydroxy bond. So both assertion and reason are true, and the reason is the correct explanation of assertion. Alright, so that is all for today. Let me see if you have any comments so far. Okay. Good evening, everyone. Okay, no relevant question. No issues. Alright. So if you face any doubts, you can ask us in the comment box. We will post this PDF in the description also, so you can see the rest of the questions. Those are your homework, and we have covered the concepts in the beginning. If you have joined late, please try to revisit the concept first before answering the questions. The concepts will help you immensely. Okay, so that is all for today, everyone. In the next session, we will come with another chapter from your EAPCET series. Okay. Okay, the board is also not responding. Okay, it is responding now. All right. Yes. So we will once again come back with the next chapter in the next session. So try to follow the sessions. It will help you immensely in your EAPCET preparation. And if you want more such concepts, more such questions, more such important information, you can download our app also. Please subscribe to our sisyaclass YouTube channel, download our app, and you will get more such amazing content. Okay, so that is all for today. Have a great day, everyone.